Tina, Jerry King, how are you?
Good.
Good. Michael,
Yeah.
here's my card, and everybody else I think I've met. And here's one, if you guys want to have one to look on, that'd be great. I'd like to have it back, since you don't use them day to day, but I'll leave one back here in case you get curious and want to talk about this. The other thing I'll do here real quick is our line card has been redone as of last week, and we can talk a little bit more about all the other stuff that we do maybe at the end real briefly. The purpose of this discussion today is Sharpe, and principally Sharpe Valve valves. So for those of you who know or don't know, Sharpe is a division of Smith Cooper International. They're based in California. They have warehousing and distribution centers in Atlanta and Houston and California and Chicago primarily. They are a privately held company that's owned by a venture capital group, and they are about 175 million in sales, something like that. So they're not a small company by any means. The Sharpe name comes from the original company that was headquartered in Chicago years ago. It was acquired by Smith Cooper. It was previously known as Sharon Pipe. And so when they acquired Sharon Pipe a number of years ago, they discontinued all the trade names for everything in the product line and integrated it into Smith Cooper with the exception of Sharpe, and they kept the brand Sharpe. So that's the sort of genesis of the name. Just so you know, I've been in the valve industry for an embarrassingly long amount of time. I started in the valve industry in the mid-1970s, and I was with the ITT Valve Group in Lancaster for 25, 26, 27 years, something like that, and left there in 2008. We started Summit Controls 2 years ago, and we focus really on what I'll call process valves, and Sharpe would be about the least sophisticated of everything that we do. So we would get involved in heavy industries. I have a lot of experience in those particular areas. The nice thing about the heavy industries is that the valves get more and more expensive and more profitable. So, it's the idea of getting into some of those industries. So what I want to do today is kind of have a discussion that centers around this catalog as an outline. And we've been waiting on this book for a couple of years, actually, and Smith Cooper does everything overseas. They do all their printing overseas. They do. I think they did their design here, but they're not that quick to get stuff to market in terms of the promotional pieces. But I think they've knocked it out of the park with this one. One of the things about the Sharpe line is that they have so many products in it that are labeled Sharpe, and it's kind of difficult to discern. Okay, which one do I use here, or which one do I use there? And what I like about this catalog is that it can be used as a reference piece, especially on the inside, and it's very logical the way it's laid out. And I think it can be used as a sales piece, a presentation piece, to sit down in front of a customer and open it up and kind of take them on a guided tour. There may be more information in this book than you actually want to give to a customer, but I would urge you to carry this around and use it as a sales presentation piece, because I think it's that good. So, if you look at the beginning part of it, in here we talk about in the first few pages, sort of page 4 and 5 and 6 and 7, they talk about the high performance ball valve product, and that's really what this entire catalog is about. And even though there's a lot of configurations in here, different configurations, it's all built on the same basic platform, and all the components more or less are interchangeable. So there's a couple of things that drove the design of the high performance valve. One of them is this specification that's called API 608. And API 608 is a sort of standardized version of 3-piece and 2-piece ball valves, it takes into consideration the critical nature of the applications that they go into. Here to now, you could have 30 manufacturers that would make a ball valve, and they'd all make it a little bit differently and talk about how robust it was and what have you, but there was no standardization. So it led to problems like stem twisting or stem leakage or reduced number of cycles or whatever it might be. So there's a lot of those kinds of issues that come into play in this industry. Well, API has sought to create some standards that, in order to be labeled as an API 608 valve, you adhere to those standards. And a lot of the things center around the connections between the components. So the first thing you see on page 5 at the top is that we've got a stainless steel handle, and it's not only a stainless steel handle, but it's a cast handle as opposed to a stamped steel handle. And the beauty of that is that they tend not to round out with over torquing. So this kind of gives you a sample of the cast handle. So then the second item there's an optional tamper-proof locking device, and it's actually on that valve right there, and it's set up such that once you put a padlock on the top of that, you cannot turn the valve. All right, and again, that's a casting. It's a very robust piece. The third part of the design is the connection itself between the stem and the ball. It's an extra deep slot, extra wide in the ball, and then the tang on the stem that makes that connection. It almost makes the ball and stem integral. You'll see also a little on page 5 in that center photograph where it talks about large heavy-duty stem. You see a little dot kind of in the middle of that stem. That's actually a grounding device. There's a spring in there, and it provides that electrical continuity between the stem and the body of the valve, so that you don't accidentally arc a spark. The fourth item down here talks about integral fugitive emission ports. Now, none of these that you have here, they're not actually drilled, but if you look at the boss on the stem itself, you can see that it's heavy enough that it can be drilled. In fact, the 3-piece valve here that Jim has in the middle of it. So this is the place where the boss would be drilled through. It would be threaded, and it would go through into the packing. And in the middle of the packing, you'll see there's 2 sets of packing at the top and at the bottom. In the middle, there's a little stainless device. It's called a lantern ring. And the lantern ring, they've been used for different things over the years. They in critical service, they were used to put a nitrogen pad on. So let's say you had a toxic or a very critical application like hydrogen fluoride or chlorine or phosgene or what have you. They would actually, some plants, and you won't find them in this area, but down on the Gulf Coast we had them all the time, they would actually run a nitrogen line that was pressurized, and they would pressurize that port. And if something happened to the packing that it was compromised in some way, instead of leaking out, it would leak nitrogen into the system. They would be able to record a pressure drop in the nitrogen system, and they would know that they had a leak somewhere before it actually got to the atmosphere. So, and they were doing that in the 1980s. Very, very common in chlorine plants and that type of thing. Today, the idea of fugitive emission is that the EPA monitors leaks in every one of these chemical plants and every one of the refineries, and they're audited over time, and if they have leaks, they are fined for those leaks. That's a piece of legislation that started about 10 years ago, and it's made it full circle to now where it is implemented. So
I had a conversation, for instance, with a gentleman at Braskem in Philadelphia. They're on the side of the old Sunoco refinery. And they're very concerned about this. And so all the valves that they buy have these tapped bosses, and then they actually run them to a pressure transmitter. And if they have a leak, then they will be able to detect it on their control system, and they'll know which valve is leaking and where, or where the packing is compromised. So the idea of the lantern ring then is that even if you have the leak, it'll make it to the lantern ring, but it actually won't go external, and you'll be able to detect it before it becomes a problem. So it's a real good conversation to have with people who are in the chemical industry. So then the fifth sketch down here talks about the stem seal, the different stem seal configurations. And if you swing over to page 8, it talks a little bit about those stem assemblies. So I've kind of passed these around a little bit. These are some of the standard stem assemblies. One of the things I really like about the Sharpe design is that they've created these cool little locking devices on the top, so that when they tighten down the nut, this fits over the top of it and locks it in place, so it can't be jimmied with. All right. Underneath that nut is two sets of Belleville washers. You know what Belleville washers are? Everybody knows what they are? Okay. So Belleville washer is a cupped washer. It's made of spring material, usually Inconel. And these things are designed so that they're convex, and they're put together so that the two convex sides face each other. And they're designed to be tightened down only to the point where they're flat. And what that does is it puts a constant load on the packing. It doesn't serve any purpose to over tighten them, because if you tighten them down flat, then you've defeated the purpose of the Bellevilles. So there's two sets of Bellevilles here, and then the packing ring. There's a bearing surface here. It can be made of different material, and then this of course is graphite on this stem. You can see that little continuity device there as well. So that's kind of the standard device.
Cross-thread.
You put that on. Then, again on page 8, if you look at the top, you'll see that you can have just standard packing rings, as you see here, all right, which would be the standard stacked packing. And then on the right, you can see it says Chevron. Anybody remember the Chevron gas stations? I never knew what a Chevron was until I got in the valve industry. So a Chevron basically, and you probably sell Chevron packings for other things, do you not? Yeah. So the Chevron is a V at the bottom and a inverted V at the top. And basically these things fit together in a series all the way down. And then when they're compressed, and we want the V's facing down, when they're compressed, it takes those V's and forces them out so that they seal both against the stem and they seal against the inside of the packing gland. And the idea here, again, is that any pressure that would make it past his shoulder and up into this area applies extra force to the chevrons and actually forces it outward and helps it mitigate leakage. So that's the stack packing design. And again, you can see that those fugitive emission, the lantern ring arrangements, and the different arrangements are available with any of the packing options. Okay.
So that's the basic design of the product. Swing back to page 10, talks a little bit about the different accessories. Because it's a three-piece valve, it can have different ends on it. It could be socket weld, it could be butt weld, it can have an extension. They might want an extension on the valve if they're going to weld the valve into the line and not want to disassemble it. They can put those extended ends on. Sometimes they call them pups in order to facilitate that in-line welding. As I said, everything on here is modular, so we have stem extensions that are available. Again, we can do ports for monitoring in these various extensions, and as you can see, these can either be manual or they can be modular to where we're putting actuators on them. We'll talk a little bit about that separately. But the same configuration of valve can be put together with sanitary ends on it for the food industry. It can be put into a three-way valve. It can be put into a tank bottom valve, and what have you. So page 11 gives you the pressure temperature information, and there's a description of every one of the seat materials directly under it. So you see the PT curves there. This valve is in its standard configuration is rated for 2,000 psi. Jump over to page 15, and I know that this is maybe where you want to focus on. Sometimes I can press some of these little flags if somebody wants to mark the pages, but this is where the figure number matrix is for this product. So the figure 8089 is a standard packing valve. The FS stands for fugitive emission, and so the figure 80 and 89, you basically put your part numbers together from this particular page. So we flip over to page 16, and again, this is part of your presentation. The HP stands for high pressure, it doesn't stand for high performance. So the basic difference is that the product, and of course it can be standard port or full port, but it's available with either Delrin or Virgin Peak or Graphite or the Nova seats for those higher pressure types of applications. All right? And I think you probably don't know if you know what all those materials are. Peak is an acronym for polyether ether ketone. It's a very hard, non-compressible plastic that the valve can be put together and tightened very tight. These seats, you see the way that they have a little cut on the back of them. They're designed to flex as they put the valve together. They do result in a little bit higher torque, and they're not real good in corrosive service, but they're really good in steam service. And then the Nova seat, which is carbon graphite filled Teflon, again, is more of a high temp service. You have to be careful with it in certain corrosives because the corrosive nature will go into the Teflon and it'll attack the graphite and create some porosity in the seat. So you need to be a little bit careful on how we select it. But the HP is the high pressure version of that product. So moving on, page 2021, the Series 8489 is the three-piece valve that I will call more of a commodity valve. It is a non-API 608 valve. It's the one that, again, if you have to be You have to be super competitive and still want a three-piece design that has some of the features that we talked about, easy to actuate and what have you. You'll look at the Series 84 and Series 99 valve, and when you get to page 25, again, there's a figure number chart. So every one of these sections gives you the basic design of the different products, which heretofore we didn't have this in any of this literature. Gives you the pressure temperature charts for each one of the valves based upon the seat and seal arrangements that you put in them, and it gives you the full figure number on how to order. You don't have to know these figure numbers in order to get prices, as you know. You can send something off to Mike Holowati in Chicago and say, you know, I've got this application, it's this temperature, it's this pressure, it's this media, I need these sizes, and, you know, I'm open to, you know, whatever you might suggest, and he will come back and give you a quote, but the quote is gonna have a figure number in it, so this is a real quick reference for you to say, oh, what is that? Okay, it's a 2, it's an R, and what have you, so I think this is really helpful for that purpose.
Yeah, because we have to set them up in our system, so that'll help.
Yeah, great. Moving on, page 26. This is the high pressure class 2500 valve. This valve's rated for 6,000 psi, so it's a heavy duty threaded valve. Can be produced with welded ends as well. That would be oriented kind of towards the power industry or the hydraulic industry. It's not in the same vein with Cooper and that type of product, but it certainly is applicable to high pressure designs. It's a 1/4 through 2 inch valve, and rated. Hammer. So an ANSI class 2500 valve is rated for 6,250 pounds. Yep.
Oh, yeah. Over the
Yeah.
2,000 pound limit, some of the others we had, so this would be the valve. You get that every once in a while.
There's a lot of metal there.
Yeah.
Turbine, they're hydraulics,
Yeah.
they're pipe expander.
Okay. And again, you get to page 31. There's the ordering information on the figure numbers there. Some of this is redundant, but I think it's important to kind of. We don't carry a 2-inch valve around. It's a manly valve.
It is. And that's only a 3/4 inch, man.
So page 32, we start moving into some of the sanitary stuff. I know that you guys do a lot of stuff with Dixon. This is a product that's available off the shelf. I don't know, Jim, have you ever done any price comparisons between this product and the Dixon valve?
Can't say they really have.
It might be something to look into. Only because of all the design features and things that are in the standard valve. So just to kind of draw a comparison, you've got on page 32, we've got the Series 66. On page 44, we've got the Series 88. And if you look, the basic difference is that the 88 is an ASME BPE 2009 compliant valve. Okay, so that's the main difference. So this would be a product that you could use in clean steam in a pharmaceutical facility. BPE is really concerned about ferrite content, so in pharmaceutical applications, they want that controlled ferrite so that when they weld it into the line, they don't have carbide precipitation. So what happens is a lot of these valves, when they go into clean steam or they go into high purity water,
the water that they use in pharmaceutical applications is maintained as mineral free as they can get it. So they have these.
Is it RO water or is it?
Well, some of it's RO. Usually it's distilled. All right. And they distill this down to the point where there are virtually no minerals left in the water. And when that happens, the water becomes very unstable. They measure it by through conductivity. So they take it down and they measure it in megohms. So they can get down to 2, 3, even lower megohm water. But when they do that, that water is so unstable that it's looking to try to leach minerals out of the components, and it'll even leach. Stainless steel has iron in it, so it will want to go into and find the pores, and it will want to leach that iron back out in order to make itself more stable. So they're concerned with what's called rouging, and they're worried about the leaching of that back into the water. So keeping this ferrite content down to 5% or less when they weld it into the line, that helps prevent that rouging and things from taking place. So I don't know, does Dixon get down into, do they get into the BP compliant type stuff?
they do.
Do they?
Yeah.
Yeah. On their fittings and such, yeah.
Yeah.
So Smith Cooper does not do BP fittings. So that's the basic difference between those two products. Is one is the quality system. That we flip back to page 38. In between those two is the figure 86, which is the compression in valve. It's basically the same valve as the figure 66, but it has a compression end on it. It's not a commodity valve at all. They're fairly expensive. They're a little pricey. Okay. So moving on to page 52, we'll get into, we're now starting to talk about some of the flange valves. And this is the same basic series as the high performance valve that we talked about a few minutes ago. We were talking basically about the 3-piece valve there before, but all of those components can also be built into a flange configuration, 150, 300 valve class. We talk about, on page 52, fully compliant API 608. So that's the fugitive emission and the heavy stem engagement designs that are standard. Has all the same cast handles, all the same ball and stem connection, all the same packing arrangements, and what have you. The M in this case is the metal seated valve, so that's what the M stands for. And if we get a little further back in here, we'll see the other figure 80 and 89, 70 and 74s that are the non-metal seats. So, metal seated valves are a little bit different animal. A lot of people do them these days. We also represent Cooper that manufactures metal seated valves, and of course that product goes all the way up to whatever size that you need it. The testy thing about a metal seated valve is that these balls have to be coated, and they're typically chrome carbide. So it's a spray fuse coating that they apply on very high velocity, and then they go in and they lap this ball against the seat in order to create a shutoff. Cooper and other people do a superior job of this versus Sharpe, but they're more for severe service, critical service valve, 2,500 pound steam, 4,500 pound superheated steam, that type of thing, which this valve is not designed to do. But a metal seated valve will do well in high corrosion. It'll do well in steam service. It'll do very well in hot oil service. It's typically those applications where the temperatures get a little bit higher, than what the elastomers will withstand. So the basic design difference here is you've got a metal seat, and then behind the metal seat you've got a graphite spacer. And when you assemble the valve and everything's squeezed together, the graphite takes up replaces the Teflon or the other soft seat material and gives it the resilience that it needs in order to keep the compression of the ball. And keep in mind, these are all floating balls. So floating ball means that the pressure on the upstream side pushes the ball against the downstream seat. So it's not going to be tight on both sides, and that applies to everything that we've talked about here. Okay. So that's the metal seat.
What application you use metal seated valves on? What do you get?
Hot oil,
How well? The temperatures where the regular seats wouldn't take that.
right? Superheated steam.
Okay.
So when you get to saturated, you get into maybe lower pressure saturated steam where they're putting another 100 degrees, there's 200 degrees of superheat on top of it.
But anything abrasive probably would not work on a metal seat because it would probably.
Yeah, you'd want to go in abrasive services. You'd want to go to a Cooper style of valve. The Cooper valves, they have different types of coatings that they can put on those valves that withstand that abrasion. So you get into catalyst services and in refineries and some of those things. They'll use a metal seated valve. No, typically not in this one. The best abrasion resistant seat in a ball valve is Umphy, ultra high molecular weight polyethylene. It's great on abrasion. Umphy is used in wear pads for couplers on rail cars. Umphy is used now in artificial joints. You get your knee replaced. They have an Umphy wear pad in there.
It's so smooth, it feels like
Yeah, it's
like
really.
a soft seat,
Yeah.
doesn't it? It's just so smooth, it's
Yeah.
polished.
Perfectly machined.
Yeah.
Yeah.
So again, you'll see a lot of redundancy in terms of the documentation, but this is a real convenient way to get to a section of the catalog. It talks about a specific product and then stay in that section in order to get it to the point where you've got a completed figure number. The M80 and 89, 70, 74 goes all the way to 600 class flanged. The next section talks about chlorine valves. I can't imagine that you see any chlorine applications in this part of the world
Glatfelter might have.
anymore.
Yeah.
Glatfelter might have it.
Yeah.
They in their bleached pulp.
Yeah.
Used to.
They used to. They might be. A lot of those mills went to peroxide.
Yeah, I don't know if they used to. They used to at one time, but I don't know if they.
Yeah. So then we get back to page 68. So the V stands for V-ball. I don't think I have a V-ball here. No, I do not.
Yeah. I saw it here for 6 here.
So the V-ball is just what it says. It's a ball that has a V cut in it, and it's designed for controls, designed for throttling service. There are typically, when you get into control valves, you're going to size them for the flow and the pressure drop that the customer wants. So if somebody calls you and wants a V-ball valve or wants a control valve, you typically need to know what the media is, and you need to know what the specific gravity is. You want to know the flow rate that they're trying to achieve. You want to know what the upstream pressure is and the downstream pressure are. All that stuff is in here, and you get all that information and you send it to me or you send it to Mike Holowati, and they'll come back and tell you what characterization that you need in the valve. When we talk about characterization, those V's can be fairly thin or they can be fairly wide, and so You can have a 15-degree V, you can have a 30, or you can have a 60, depending upon what type of control you need. When you get beyond the ball valve doesn't have tremendous rangeability. By that I mean it won't give you a wide range of control in a very precise manner. But it's a good general control valve. If we want to control a level in a tank or something like that, we can do that with a valve like that. When you get to more finite control, or when you get to larger valves, where you're dealing with higher velocities, when you get into higher velocities with a control valve, it creates noise. And there are actually OSHA regulations that limit the amount of noise that can happen in a plant. So when we get into those kinds of applications, then we typically look at other types of control valves. And Summit Controls does this also, glow control valves and cage trim valves, and valves with anti-cavitation trim and that type of thing. This might be a good time to talk a little bit. On page 69, we talk a little bit about ISO 5211 integral mounting pad. Your version, eh? You might want to talk about that.
Oh, you're here. Why don't you talk?
All right. So, again, several years ago, companies got together and, through the International Standards Organization, they came up with a way to standardize the dimensions on the top of the valves and on the bottom of the actuators so that every one was virtually the same and they could be interchanged easily. Now, they can be interchanged easily and they can't. It depends on who set them up to begin with. Sam and I visited steel company that had some actuators and that wanted to retrofit, and they could have done it easily enough. The dimensions are the same, but they would have had to do some work on the coupling. So we have a bracket. Typically there's a bracket. The actuator sets on top of it, and then in the middle there's a coupling. These brackets, in many cases, typically are made out of channel that they simply cut off and they drill it and put it together. Sharpe has gone down the road of actually creating this in 304 stainless steel. So this is just a standard bracket and it's very, very robust. So it can be arranged like this. Better yet, now this is a Series 13 valve. This is not the high performance valve. You can find this valve on the Sharpe website. So the Series 13 is a 3-piece, Series 11 is a 2-piece, and it's called a direct mount valve. And the direct mount means that you don't need a coupling. It means that this ISO dimension matches this dimension on the bottom of the actuator, and depending upon what size valve you're putting it on, there's little bushings that fit in here so that this actuator can fit right down on top of the valve and be put together with nuts underneath and bolted in place without coupling. So we've actually had some conversation about the direct mount approach when you guys decide to get back into actuation. One of the cool things about this, and I guess valve people like cool stuff, and you look at this and you say, well, what happens if you put the actuator on there and you have to adjust the packing? Sharpe patented this design several years ago, and if you look at the nut in the top of here, there's the Allen screw here, and you can actually go in and loosen the Allen screw and then take an Allen wrench and turn that through this location here, tighten it, stop the leak, reset the screw, and you're back in shape.
I know. I thought it was just a cutaway so you can see.
Yeah. So something about the control valves again. Page 73 at the bottom, you can see a visual of what that V ball looks like as it sets up against the seat in the open position. And the other thing that's interesting to note is when you get into a control application, even this type of arrangement has enough play or slop in it that they want to try to eliminate that because they want it to be very precise. They call it hysteresis, and they want to eliminate that hysteresis. And they do that by putting a no-play coupling on, and that coupling has no play whatsoever. So it gives it the ability to, have very precise control. Page 76 is the ordering information for the V-Series valve. Basically, the same type of arrangement as the other figure number charts.
Gary,
Sir,
why would someone want to use the 4x4 versus the older style rack and pinion actuators?
good question. You're getting a little ahead of me, but let's go ahead and talk about it. So the question was, why would you want to use this style of product versus this style? So the basic difference, these are both what are called a rack and pinion actuator. So we've got the pistons that have a casting that have a rack built on it, and those push together and they twist the pinion in the middle of it. And so air is applied, it's ported through the actuator into the center or into the ends. So if you're powering it air to open, air to close, you're using air on both sides. If you're using an air to open, spring to close, you're putting air into the center. It's spreading the pistons apart by air. When the air is let off or released, then the springs force the pistons back to the center and close it. So this is the same design, but it has 4 pistons. So why 4 pistons
As opposed to 2, or just 4 pistons in general?
as opposed to 2?
More uniform compression and
That could be part of more power. Exactly. It's a. I guess we all took geometry, right?
6-cylinder to V.
yeah, okay.
So you can use a smaller actuator to achieve the same amount of torque. So if somebody has a space restriction, they want something small and compact, or they just visually want it small and compact, they'll use this type of actuator. Pharmaceutical firms are famous for piston actuators because they want everything tight and clean. They don't want all this, they don't want big pieces of equipment. So that's the main difference. They're a bit more expensive because you have 4 pistons. Right?
But you're gonna get more power in tight space.
So they're going to be more expensive on a dollar per inch pound basis. It doesn't matter. They're just going to be more expensive. All right, but it's just a cleaner application. That's a good question. Good question.
Do they make the V84 in a 2.5 inch now? I see it listed in the front, but they don't have any specs in the back.
I don't know the answer to that. Where did you
They
see it? Where did you see it
listed
listed?
on page 71.
Listed on 76 in the how to order.
But
That
there's
size.
no CD values on 72 for 2.5 inch. I know they didn't make it at one time. I wonder if they make it now.
That's correct. It's on the size chart for how to order.
Yeah, it's a good question. You want an answer to that question?
Sometimes, not review right now. Yes. There's such a big jump from when you're sized it from the 2 inch up to the 3 inch.
Yeah, a lot of cases they're probably using the same body for the 2 and or the 2.5 and 3. So let me check on it.
Okay, so time. So jumping over to page 85, this is the cryogenic product. Again, the body, the internals, everything is essentially the same. We're just getting into an arrangement whereby the packing is removed from the flow path. It's moved out of the flow path so that it doesn't get frozen in place in a cryogenic application. So that's.
I don't think we have any cryogenic applications. do we?
One sport project.
One customer does that.
Some of your food process guys might get into that a little bit if they're handling liquid nitrogen or what have you. You know, air products or any of those guys. They would have those types of applications.
I think Dan's quoted some cryogenic
Yeah.
before.
If you have LNG facilities where they're liquefying natural gas, they will have these products. So, I mean, you know, Philadelphia Gas, Sunoco, they all have cryogenic applications. Again, some of this is redundant, but you can get to page 97. Here's the figure 70 and the FS70, which is again the API 608 compliant. I mean, from an inside sales standpoint, do you ever hear, has a customer ever asked about API 608? No?
You'll see it sometimes in the specs when they come.
Most only.
Yeah,
Petroleum, yes.
sometime in the
the-
spec.
The
Yeah.
FS 5114s down there, I stock them for Rust-Oleum.
Oh, okay. All right.
Yeah, we have 3 sizes of those in stock.
Yeah.
So you have the standard, you have the full port that's on page 96, and then on page 104 is the standard port valve. And again, all of the packing arrangements. Yeah. Now the fire safe spec is API 607, and this product complies with the sixth edition. One of the things about I guess I'd have to ask the question: Do you get requirements or requests for API 607 fire safe?
If you don't take spec, we see that we're still in contract, they get that too.
Okay.
We see sometimes contractors are coming on spec.
That's very wild.
Yeah, one of the things to ask is, one of the things to be careful of is whether if they want a true API 607 product, it should be the 6th edition. Their API is moving into the 7th edition right now, and it allows you to sell a product that is 1 or 2 editions back. So if they're asking for 7th edition, you can sell a product that is the 6th or 5th edition, but you can't do a 4th edition. So there was a 4th edition product in Sharpe's lineup that they've now taken out because they can no longer call it a compliant product. Okay, so it's just something to be careful of when you're chatting with your customers about that. And I guess the only other thing that I had,
No, the feature of emission port,
Yeah.
that has to be, that's not a standard
you have to order it.
feature, okay.
Yeah, you have to order it, and you're typically going to order that with a lantern ring in it. So there's two separate ordering points there for that. Okay. Any questions about the,
I'm a pro at that now.
what's that?
Three-way ball
Four ways,
valves.
the 4 ways, the
Yeah.
T-type, the
Yeah.
L4s.
The flush bottom tank valves.
Yes, sir.
You can't just switch a PVM out and put Sharpe in there, right? You gotta have the tank pad that's specific to.
I don't think they're interchangeable. I'd be highly, highly surprised if they are.
I wouldn't think that.
Yeah. I haven't ever asked the question, I've never really checked the dimensions, but if I was Sharpe, I would have made it
Right.
interchangeable, but if I was PBM, I probably would have
wanted to make it difficult to do.
A special thing on the tank, then you can put your valve right to it.
Questions?
But it's not.
Lots of information you'll never use.
That's good.
Makes you surprised.
Yeah, maybe?
No,
Okay.
you need spec sheets on the website, Sharpe's a good website, just go to products and
Absolutely.
all the spec sheets are boom, right there. It's all, yeah, real easy to figure out, they have it down by series,
And a lot of times with, if it's just like the basic configurations, I can pull the pricing right off of the Smith Cooper website. They don't even show how many they have in stock, so.
Right.
But
Okay.
I like to talk to Michael.
Well, I'm just saying, if you needed something really quick.
Just in passing, I think we've got another group coming in here in a minute, right? So I'm gonna leave these, we don't have to talk about this a lot, right now. But on the sales side, and I'll leave that with you too. So this company, Southern California Valve, you'll get an announcement from Summit Controls probably next week, talking about our taking on this line.
Wow, they're different.
And so I show this to you because these guys are capable of doing all kinds of things that other companies are not. So the message here is, if you're looking at Sharpe or you're looking at any other line and you see a requirement that Sharpe can't quite do, or there's some limitations in what Sharpe can do, call me, because we have all kinds of options. They do floating 2-piece ball valves, and they do 3-piece valves. It's really not, their strong suit. Their strong suit are going to be trunnion ball valves, through conduit gate valves, pressure sealed valves, lubricated plug valves. So a lot of this is going into API types of services. So if you're doing work with Buckeye Partners or Sunoco Logistics or any of the pipeline companies, these products fit into that category. If you've got a customer that says, I need a double block and bleed valve, we talked a little bit about how this valve is a unidirectional valve. It seals, it's a floating ball and it seals in one direction. If you need sometimes a customer will say, I need it to block in both directions, and then I want to bleed off the pressure that's in the cavity. We can achieve that with a trunnion valve. So, and it's achieved because the seats on both sides are spring-loaded and forced against the ball, and the ball itself is anchored by a trunnion, which is simply, you've got a stem on the top and a stem on the bottom, and it's anchored into the bottom of the body so that the ball won't float in any way. All the compression comes from the seats on both sides, pushing against the ball itself. These guys do a great job on wafer check valves. We use these guys for wafer check valves, sometimes on quick delivery when we can't get them from Advance. But we have two great sources. If you have requests for Crane Duo Check or some of those types of brands, we can fill the bill with either Advance or this product line. They are a U.S. manufacturer, so everything comes out of Houston. So they comply with Buy America. They don't comply with Buy American because their castings do come from overseas, but they have sufficient content in order to be able to certify the valve as an American-made valve. And if you need additional information on any of these product lines, there's separate catalogs for each one of these.
Can you bring a 42-inch in, trunnion in as a sample, just so we can take a look at it?
No, but you know what? I happen to have a photograph right here. I was in Houston a few weeks ago. I happen to have a photograph of a 42-inch trunnion.
roll that ball down the street.
Fact,
How
fact,
much that costs?
You could walk.
Probably 20.
there you go, see,
more than that.
it says 42, 600 pound, right? Well, there's the valve.
That's insane.
Oh my God.
It has a Rotork actuator on it. The valve weighs 52,000 pounds.
Jeez.
How much torque does it take to rotate
A lot.
Just hand operated.
the tan? Yeah, just a lever. Just a lever.
These are going into probably a refinery or a pipeline,
14-foot lever.
high pressure pipeline. These
The
valves
wheels are big as the
shipping to-
wall.
Pretty good cheater bar on that one. It's like a football field away.
And they're, these were about $160,000 a copy.
If you sell one of those, you get salesman a month. If you sell one, you get salesman a month.
I'm sure.
Yeah,
Wow. A lot of dollars.
Yeah.
probably at 0.004%
Yeah.
margin.
Nobody else is gonna have it. Mark it up.
Yep.
Yeah. Well, and these guys, they do stock heavily on this type of product. They don't keep 42-inch valves in stock, but. So.
Okay,
Yeah.
thank you.
All right, guys, thank you. Okay, thank you very much. Thanks for being here.
Thank you.
Thank you.
You gonna record the second session as well, or,